When we talk about pollution, what are we talking about? What exactly comprises our pollution? So let's look at some types of air pollution. So we have things called particulate matter, so tiny, tiny little things that we breathe in and inhale. Nitrogen oxides, so compounds that contain nitrogen and oxygen. Sometimes you'll see them abbreviated as these NOx compounds because there's various different nitrogen oxides, and so the X there stands for various different numbers of oxygens. Same thing with sulfur oxides. We have sulfur with some number of oxygens, carbon with some number of oxygens. Hydrocarbons. So these are organic molecules. Hydro for hydrogen, carbon for carbon. So hydrocarbons contain only hydrogen and carbon. And ozone. So ozone's an interesting compound, interesting molecule. So we have our ozone layer, and that's really important. We need the ozone layer, but ozone is also a pollutant. And so sometimes it can also depend on where in the atmosphere the ozone is located, whether or not it is doing its job in the ozone layer or it's polluting. Ozone is O3. Okay, ozone's interesting. Here, I'll draw one of the resonance structures for ozone here. Okay, so I can draw this two ways. I can draw it with that double bond between the first and second oxygen, or with between the second and third. What we actually see is something called resonance, where we see that double bond character. The electrons are delocalized, meaning that they're not stuck in one spot, they move around. But anyway, that's what ozone is it's this O3 molecule. And so it can be both a really good thing, and surprisingly, it can also be harmful as well. All right, so when we think about particulate matter, okay, particulate matter, we've got stuff that's in the air. So thousands of different solid or liquid particles that are suspended in air. So anything like tiny soil particles, soot, lead, asbestos, salt, sulfuric acid droplets, all this stuff, this is all particulate matter. So why is it bad? Well, it can contain material that in and of itself is bad, that can be toxic or carcinogenic. Like, I don't want to breathe sulfuric acid. That's not a good idea. And then those tiny particles can build up and become lodged in our lungs. And so that's not good to have a bunch of junk in our lungs. All right, so our nitrogen oxides, these NOx compounds. So what's happening here is we have nitrogen in the atmosphere, we have oxygen, and so gases are produced when we have interactions between atmospheric nitrogen and oxygen at high temperature. Okay, and so we see these in like this brown haze sometimes above or downwind of cities. So we can see them suspended in the air because they're very gross looking. All right, and so yeah, we get those chemical interactions between nitrogen and oxygen, and they occur at high temperatures. And so if we have a situation where we have a high temperature, environment, and we've got atmosphere, and we've got nitrogen, and we have oxygen, we can react to form these nitrogen oxide compounds. So they can occur naturally, but they can also occur at the site where things are burning. And so we can get nitrogen oxides formed from things like, when our cars are running, because all that's being done at very high temperatures. So those are our nitrogen oxides. The sulfur oxides. So what's happening here? We get reactions between sulfur and oxygen. These are emitted from burning coal and oil is where we get a lot of these sulfur compounds. Now, what ends up happening with our sulfur oxides is they do react with water and they end up forming acids. And so what ends up happening is then that acidifies the water in our atmosphere and we get acid rain. So I have two pictures here. This is what can happen with acid rain. So what occurs is you've got marble. Now marble, if I expose it to water, the water's just going to run off of it. But if I expose marble to an acidic compound, it's going to erode it away. And this is because there's a reaction that occurs between acid and marble. So marble, we have calcium carbonate. Carbonate is a polyatomic anion, meaning it's something that's negatively charged that has multiple atoms in it. Okay. What makes an acid acidic is the hydrogen ions. So I get this reaction. I have two hydrogen ions that are in water. That AQ means aqueous, so it's dissolved in water. I get this carbonate, okay? And at this point, what's happened is I have, because of this acid rain, this reaction that's occurring, I've dissolved the carbonate in water. So again, water is not going to dissolve marble, but acid will. Okay? Now, what ends up happening is it can form an unstable compound called carbonic acid. Now, carbonic acid does not stick around. Carbonic acid decomposes immediately into carbon dioxide, which is a gas, and water. And so the gas, the carbon dioxide, it bubbles away, and then the water just washes away. And so acid will dissolve marble. And so we can get all this erosion of marble statuary from rain that's been acidified by these sulfur compounds getting into the air. Okay. All right, carbon oxides are two big ones, carbon monoxide and carbon dioxide. So these are what we call greenhouse gases. So these are some of the gases that are absolutely contributing to the warming of Earth and our atmosphere. And what's actually really interesting is that we knew that these compounds were going to do that like over 100 years ago. We just didn't do anything about it before it got really bad. If we go back to calculations that people made during the Industrial Revolution, predicting exactly what we're seeing today with the temperature of the Earth rising, the calculations are very, very good to what we're actually seeing. So they contribute to this greenhouse effect. They absorb something called IR, which is infrared radiation. So everything vibrates. If I have a molecule, it's not just sitting there. It's vibrating, it's moving. And so those vibrations, they absorb this infrared radiation. And so when sunlight and stuff hits that, we get radiation, absorbs this, and so we start seeing things that are not good. Other greenhouse gases, chlorofluorocarbons, some of those nitrogen oxides, ozone. Ozone is actually a greenhouse gas. Again, we need our ozone layer, but ozone floating around in the atmosphere is actually a greenhouse gas. It absorbs this infrared radiation too, and it is contributing to pollution and the warming and the climate change effect that we're seeing. Okay, hydrocarbons. Like I said, organic compounds only contain hydrogen and carbon, and so methane, CH4, okay, that's going to be one of the hydrocarbons. Ethane, so a lot of the fuels that we have are these hydrocarbons. Propane, that's 3 carbons, okay? And so these get related to that photochemical smog. And again, guess what? Greenhouse gases. A lot of the stuff that we produce is a greenhouse gas and reacts with stuff and does stuff that we don't want to have happen. Okay? So when we talk about ozone, all right? So we have our ozone layer. Again, we like the ozone layer. However, ozone that's in the wrong spot is not necessarily good. So we've got this diagram here that shows the troposphere, the ozone layer, and the stratosphere. Okay, so we've got these different regions of our atmosphere. So in the troposphere, ozone, that's lower atmosphere ozone. This is man-made. It is a secondary air pollutant, so meaning that reactions occur, and it is a component of that photochemical smog. So ozone in the troposphere, we don't like it in the troposphere. Now, stratospheric ozone, okay? This is what the good ozone is. So it's kind of weird. In one situation, we don't want ozone, but in another situation, we do want ozone. We do want stratospheric ozone because this is what is screening out UV radiation coming from the sun and everything. Now, some of our man-made pollutants, like those chlorofluorocarbons, that reacts with our ozone and can deplete the ozone layer. So when we used to emit a lot more CFCs, there was a gigantic hole in the ozone layer. We actually have seen it shrink as we don't use as many CFCs. But what's actually interesting is different times of the year we see different effects with the ozone layer based upon air current movement and the temperature of the air and what's getting trapped at certain times of the year. And so we can actually see a fluctuation in holes in the ozone layer based upon the time of year. And the location of the hole you may think is really weird because it's not necessarily above like the worst polluting city. And that again has to do with air currents and how things get trapped in the air at different temperatures and things. When we look at the ozone layer depletion, again, our ozone layer initially is very good. It shields us from all these UV rays when we're up in the stratosphere. So we get these CFCs, so things like aerosols. So this is why aerosols are not used the same way they used to be. When I was a kid, oh my goodness, we used so many aerosols back in the 80s. Refrigerants, solvents, there's these HCFCs, which are a different classification of the chlorofluorocarbons. Again, refrigerants, solvents. If your car air conditioning system was depleted, it never used to be a thing to go have it recharged. You just bought the stuff and you could put it in or you could take it to a mechanic, but that stuff's highly regulated now, or we can't get it anymore because we've learned that this stuff is not good for our environment. Fire extinguishers. So if we were all setting off fire extinguishers all the time, that wouldn't be good. And then some of the pesticides that we use also deplete the ozone layer. And so we'll look more at reactions in a little bit, but basically we've got these CFC molecules. So chlorofluorocarbon. So chloro, chlorine, fluoro, fluorine, carbon, carbon. So these are compounds that contain carbon, fluorine, and hydrogen. And I'm so used to hydrocarbons. Carbon, fluorine, and chlorine. All right, and so those react with our ozone, and ozone is highly reactive. And so then it splits off into other things. So then we get like an O2 oxygen molecule, and then we get something like a chlorine oxide compound. Okay, and so then that depletes the ozone. We end up getting this hole. Compounds are then going to continue reacting. Some of these cause a chain reaction to occur, or once we start making this reaction, then other things continue to react. So it takes a lot of work to get this out of the atmosphere. All right, and then other things to think about, VOCs, volatile organic compounds, so hydrocarbon fuel vapors, solvents. So volatile, these are things that have very low boiling points. Boiling point is the point at which something goes from a liquid to a gas. So water has a high boiling point. We have to get it to 100 degrees Celsius in order to boil it. But a lot of these volatile organics, these have such low boiling points that they will evaporate, so go from a liquid to a gas fairly readily even at room temperature. There are some things where if you spill it and then you wipe it up, it's already evaporating as you wipe it up. Toxic metals, these will pollute the air. These get into our air, so lead, cadmium, copper, things like that. Again, our chlorofluorocarbons, ammonia, that's harmful to our air. And then radioactive pollutants that happen from nuclear explosions or war or natural processes such as radon. That is radioactive and that comes from natural processes. So we're never going to completely manage to get rid of air pollution. Again, natural things occur. Volcanoes erupting, forest fires, stuff like that. We can't stop all of that. We can't completely control our air from never being polluted. But there's a lot of things that are man-created that we do need to examine and try and mitigate.